Hi, I'm Kevin, and today we'll be doing Leetcode number 3, which is longest substring without repeating characters, and it's a medium problem. So the goal is, given a string s, return the length of the longest substring without repeating characters. So repeating characters literally means any repeating character. So if it's AA, then you could only say the longest substring without repeating characters is 1. But we'll go through more examples later. The constraints are pretty simple. The length of the string does not exceed 5,000 characters, and the string is composed of English letters, digits, symbols, and spaces. So the first example is this string of 8 characters, so ABC, ABC, BB. And the output should be 3, because ABC is the longest string that does not repeat. And ABCA is not a valid string because the A's are repeating. The second example is BBBB, 5 B's, and basically it's just 1 because there's only one string that does not repeat. And example 3 is a case where it's in between the start and the end, so PWW, KEW. WKE in the middle is the longest string. So intuitively, all we have to do is, find all the substrings, remove the ones that have repeated, and then count the length of the longest string of the characters remaining. So let's see how efficient that is. So for our original 8, example 1, 8 length string, we have a bunch of substrings. So A, AB, ABC, and so on. So pretty much the first row is the full string, one character added at a time, and then the second row is without the A. So yeah, you can follow along the patterns here. And now we have to remove all the strings with repeated characters. So these are all the strings with repeated characters, and what you can see here is that after you find the first kind of repetition or invalid substring, all the future strings will just be the first substring that's already invalid plus additional characters. So every substring after this is also invalid. So we're actually wasting a lot of time and effort kind of checking all of these or like writing these all out. So we want to find a way where we can just check this, like find the ones that are very close to the edge and don't over process all of these highlighted in orange. So checking every substring in the string of n characters long uses a double for loop, which is O of n squared. And for long strings, this can take a long time. So pretty much, if you imagine ABC, you just have like a million rows and a million columns, basically. And you're doing this huge million times million kind of substring calculation. And that doesn't seem very efficient. So there has to be a better way, basically. And now this is where this tool comes in. It's called a sliding window. So a sliding window is useful if you want to analyze subsequence of data. So it breaks down a long string or an array into smaller pieces, and it can adjust based on what it finds or provides. So for example, let's say we have a short string here, 4 characters, A, B, C. The window starts, the left of the window is at 0, and the right of the window is at 1. So this is just encapsulating A. right? And then we check the next character, and it's also an A. So because we're repeating the A's, or this A is already in the substring, then we don't want to repeat it. So we need to move our window. So basically the left of the window moves here, and the right of the window moves to add this A. So now the new window looks like this. And now we add B to the window. And B is not in A, in the string A, so AB is a valid non-repeating string. So the window now holds 2 characters. And adding C, the window holds 3 characters. So the length of the window right now went from 0 to 1 to 1 to 2 to 3. And the longest substring is 3, ABC. So let's see this in action for the original example 1 of 8 characters. So first, the window starts at A, and then it encapsulates B, and then C with no problems, ABC. And now the A repeats, so this A drop, and then BCA, and repeat again, or CAB, and then again, so now you have ABC again, and this B being added, I want you to notice how when we add this B to the C, we're dropping 2 things. So we're dropping A and B, because when the window moves, you move the left of the window all the way so that you drop the actual repeating character. So if you only remove one character, you're going to end up with BCB, and that's not valid because the B's are repeating. So you actually need to make sure that you move the left of the window so that it does not contain this character. And I'll show you how to do that later. So that's what happened by dropping these 2 here. And again, B drops C and B. So how do we know when a character is repeated? How do we use a tool to help us identify that scenario? So we can use something called a set. So a set is a data structure that contains unique values. And by using a set, we can check if the new character we are evaluating is already in the current substring. So this is the actual code, Python 3. And here on the third line, we create an empty set and we set it to char set. The fourth and fifth line are defining variables. So the left window is pretty much initialized at 0 because it's all the way on the left. And the max sublength is set to 0. And this is the value that we'll be updating as we run the program to update the values of the longest substring that we can find. And now the loop. So for right window, in range of length of S. So S is the string that's up to 5,000 characters long. And right window, we want to make sure that we are checking every single character in the string. So right window will move all the way from the very beginning all the way to the end of the string. So we can use that as our iteration kind of variable. So while S, right window, is in character set. So what this while loop does is, this is the check, this is the condition that checks if the new character is already in the set. So if it is, we're going to remove the character, whatever character is on the left, and we update the window value to increase. So this is basically sliding the left window edge closer to the right until it drops all the repeated characters, or one repeated character. And then we add it again. So we add the repeated character, and that's basically doing, when it recognizes this B, it's dropping A, and then the while loop triggers again and it drops the B, and then the while loop finishes and we add the B again. And then we check if the maximum sublength has changed. So we use the max. So the original max sublength and right window minus left window plus 1. So what this does is, imagine there's numbers here. So 0, 1, 2, 3, 4, 5, 6, 7, 8. And basically, as we are updating the window, we are actually using the window length to identify the length of the maximum substring. So we don't have to actually know that ABC is 3 characters, because we can just say the window is currently 0, 1, 2, 3, 4, 5, 6. So the window is basically between 3 and 6, which is 3 characters. And then we just return it. So for time and space and complexity, by using a sliding window, we're only iterating through the string one time, which leads to an O of n solution. And by using a set to store and retain values, we are using O of n memory, as the worst case scenario is that all the characters are unique and all the characters are added to the set of numbers, or not numbers, characters. And that's how you solve longest substring without repeating characters.